All right, William, can you read us the essential question, please? Perfect. And then Henry, can you read us the I can statement? Perfect. Okay, so that's what we've been working on for a couple days here and there. Okay. We're going to get those things. We're talking through a lot of different scenarios on position, velocity, acceleration. And we've been kind of working on the conceptual, what does this really look like and mean? And we're going to make it more concrete today, and we're going to add our calculus piece into it. We're looking at it, taking the derivatives. We're looking at it from a graph standpoint. We're looking at it from tables. Actually, when I see position, velocity, acceleration, I think it's a whatchamacallit. It's an easy one, right? Because you know what to do. Okay, when we see those words. All right. So yesterday we did this example too. It was a lot of work to do that. That was kind of a ridiculous amount of work, so much that we split it up, right? We don't want to have to do that work on every single problem, okay? To try to determine whether it's moving left or moving right, or speeding up or slowing down, or any of those things, okay? So we're going to work on things that we want to look at is knowing what direction the particle's moving, when the particle stopped, and when it is speeding up or slowing down. Okay, so those three things typically come up on the exam in some way, shape, or form, or fair game for the AP test. Okay, so we should know when we do those things. Okay, so we're going to fill in each box, and then with either the phrases speeding up, slowing down, constant speed, or stopped. Okay, before we do that, we talked a little bit about this yesterday. Can you write next to the acceleration greater than 0 and the velocity greater than 0, all those little boxes, write down whether it's a positive or a negative. We're working on making sure we recognize that right now. So fill in, there's 4 of them you got to fill in. Put a plus or a minus sign. Okay, what did we put for greater than 0? On acceleration, sorry. Plus or minus? Plus. So we got positive numbers there. What's this one? Minus. What's this one down here? Plus, and this one is minus. Okay, perfect. All right, we're going to fill in the rest of the table. So when we have acceleration and velocity both positive, okay, so think about what's going on. Oh, we didn't have it on this one, did we? Oh, yes, we did. So when we have the acceleration positive, we're moving to the right, and we are being pulled to the right. So when that's happening, I'm getting faster at what I am doing. I'm having something's helping me go faster, okay? So that means we would be speeding up. Okay. All right. If we have something where we're going in the positive direction, so we're going in the positive direction for the velocity, okay, but our acceleration is negative, that means that the wind is going to push us that way, right? So that would be, remember we were talking about that yesterday. What's going to happen to me if I try to walk into the wind? What's going to happen to my speed? Is it going to increase or decrease? It's going to decrease. That means I'm going to slow down, right? So this would be slow down. All right. And then if I have a positive velocity and my acceleration is 0, meaning I'm not being pushed in the direction one way or the other, that means I'm going at a constant speed. That's cruise control, right, in the car. So that's a constant speed. All right, let's talk about the next row. So if my velocity is negative, meaning I am going in the negative direction, okay, so velocity negative, and and my acceleration is positive, meaning I'm going to get acceleration is going to come this direction at me. So again, I'm kind of going, if I'm walking to the left and then the wind is coming at me from the right, what's going to happen to my speed? Am I going to speed up or slow down? Look at how the arrows are acting on each other. Is one of them dragging the other one along, or are they pushing at each other? They're pushing at each other. When we're pushing at each other, right, that means there's some resistance there, right? So that's going to make me slow down. All right, so let's look at the velocity negative again, right? So velocity negative and acceleration negative. So acceleration is going to bring us more that way. So what's going to happen there? Is it going to speed up or slow down? So my velocity is traveling to the left. My acceleration is going to pull me more to the left. What's going to happen? I'm actually going to speed up, right? Because I'm getting pulled more that direction, and it's going to help me out, okay? So I'm going to speed up. And it seems really weird to be going negative and to speed up, right? It's counterintuitive to what our thoughts are. All right. Still, when acceleration is 0, it doesn't matter if we're going in the positive or negative direction. We're still going to be at a constant speed. Okay. No matter what's happening with acceleration, when velocity is 0, what's going on with our particle? It's stopped, right? That's what we talked about yesterday. And we saw that when we kind of did our little exploration yesterday. Okay. No, so they did this. Okay. That was on the next one. Did they do it on this one? Not really. Okay. We're just looking at what they did. All right, I'm going to summarize this. So this is what we typically think about, okay? So rather than memorizing velocity, positive acceleration, positive speed up, velocity, positive acceleration, negative slow down, okay? Let's generalize that a little bit. Do you notice how when the signs were the same, it was positive, positive, or negative, negative, we always sped up, okay? Look at the other direction. It's negative, positive, or positive, negative, we're always slowing down. So when the signs are opposite, we slow down. So let's make that notation out in the left-hand column there, okay? So same sign. Actually, you know what we should do is put velocity and acceleration, same sign. Speed up. And velocity and acceleration, opposite sign or different sign. Slow down. So you actually have to look at the values of velocity and acceleration. The little paragraph under there mentions a sign chart. We're not going to mess with that at this point. We don't need it for the examples we're going to do. They had an extra example in there that I pulled out. So, all right. Let's take a look at example 3. Okay. So, the teachers they happen to be male teachers, so I call them the guys sometimes. The guys that I borrow some of the note questions from, that I've adapted them from, they have a thing about bugs when they do position, velocity, and acceleration. So we do a lot of problems about bugs moving. So because bugs move in a little straight line, right? Okay. So the graph below models the velocity of a bug on the interval from 0 to 13. Okay. One very important thing that you need to be careful of or know exact as soon as you see a graph is to understand what is it a picture of. Okay. This is not the picture of the original function, right? It tells us right here, and it's labeled on the graph that we're looking at a picture of the velocity. Okay. It's very typical on the AP exam that it actually is a velocity graph. Okay, so it's a very typical question. All right, so it's asking me to find the velocity at 3. Normally when we think velocity, we think derivative, but the catch is I have a picture of the velocity. So in this case, because I have the velocity graph and I'm finding velocity, I'm looking for the y value. Okay, I'm going to label v of 3. All right, so I'm going to go, we've done this a million times. What's the value of velocity at 3? Looks like 6. Good. All right. 10 seconds. Write down what the velocity at 11 is. All right, what'd you get? Everybody good with -2? Okay, perfect. All right, we've done B before. We've done the total concept. It was on the product rule, quotient rule quiz. Okay, quite a bit. So I have to find the acceleration. What's the relationship between velocity and acceleration? How do I get from velocity to acceleration? You take the derivative. What's the derivative represent? Slope. So I am going to read the slope off the graph instead of the y value. Okay. So in this case, we read the y value here, and we're going to read the slope on this one. But we have to, again, you have to be careful with what graph you're starting with. If we were starting with position, different story. Okay. All right. So acceleration at 1. So I'm going to go to 1, and I need to do the slope triangle on 1. So what is my slope at that value? Everybody okay with 2? Okay, I want you to do 5 and 9. So everybody find the slope at 5 and the slope at 9. Give you about a minute. All right, what was the slope at 5? 0, perfect. Okay, what about the slope at 9? We got to be careful, huh? -3? Everybody good with that? Okay, perfect. All right. It's asking us in the next question what time the bug turns around, and we have to give a reason for our answer. Okay. So what's going to happen is when we are talking about velocity, remember it's talking about direction. Okay. So when the velocity is positive, I am moving to the right. Okay. When the velocity turns negative, I am moving to the left. So when I have a change from positive values to negative values, the bug would turn around. Okay. We're talking about, remember, we're talking about where is the graph. So above the x-axis is positive, below the x-axis is negative. You might want to write that down. Positive values above x-axis, negative values below x-axis. And we use this concept quite a bit. Below, I don't know what I'm writing, x-axis. Okay, so what x value is it turning around in our graph from positive values to negative values? Where does that happen? Where does it cross it's I guess the t-axis, but where does it cross that x-axis to go from positive to negative? Say it louder. At 9, right? Right here, it was positive right up here, right? And it's negative down there. So all of a sudden at 9, that bug decided he needed to turn around. Okay? So we're going to write that down. So the bug turns around, and we'll write why. Okay? Around. Technically, that says the word around. My hand is going not as fast as my brain. Or my other way around. My brain's going faster than my hand. Okay, round at t equals 9. And the reason is because if you ever, because I do this a lot, sometimes I'll write just b/c for because. Okay? Because I'm lazy. The velocity changes from positive to negative. And I know I just said, hey, I use an abbreviation for because. If it was me on the AP test, I would abbreviate as little as possible. Okay? You want to be very clear in your communication to the reader that you understand it. I wouldn't abbreviate positive POS or a negative NEG. Okay? And I definitely wouldn't write the plus and the minus. Okay? Take the extra few seconds, write the word out. Okay? It's worth the points on the AP test. Okay, we good? We know he turns around at 9. All right, the next one we got to talk about is on what interval does the bug have negative acceleration? Okay, so again, what is the relationship between velocity and acceleration? How do I go from velocity to acceleration? Say it again. Take the derivative, right? So to go from velocity to acceleration, take the derivative. It's pretty much, if it's not a limit, right? It's been a while since we've done limits, right? Aren't you glad we're not taking a final? Because we don't have to do the limits again. Unless you want to re-quiz on it. All right. So velocity to acceleration, we're going to take the derivative. So, and what does the derivative represent? Slope. So isn't this a fancy way of asking for negative slope? So we need to go look at the graph and figure out where we have negative slope. All right, I want you to just highlight the graph or trace over it with your pencil or pen or whatever you're using and write. I'm not showing mine yet. I'm doing this on purpose. Draw over the top of the graph where you think the slope is negative. Okay. Where did you draw between what two x values? 7 and what? 7 and 10. Everybody good with that? See we're between those two? Okay. So the interval would be I'm looking at the wrong part. The bug has negative, and I'm abbreviating, acceleration on 7 to 10. Okay. And it doesn't tell me to write why, but I'm going to. I would say because the acceleration is negative. And then I'm also going to write in parentheses the velocity has a negative slope. So that way when you're looking at it in your notes, you can go, oh yeah, that's what we were talking about. All right. If you have your graphing calculator with you, get it out. If you don't, you can come back here and grab one of these. Some of them have battery. If not, we've got plenty up there. So you're going to need a graph. I didn't tell you to bring it, so it's my fault. If you don't have a graphing calculator, grab one. Okay, I'm going to get mine open because we're going to need it for the next couple problems. Okay. Get it on. Make sure if you borrowed one of mine, make sure it has battery, because they may or may not. I plugged the first bank in for a while. Okay. I don't want the updates right now. Okay. Oh, look, there's our friendly little bug. I didn't come up with that graphic. I borrowed it. Okay. So we're now in a different scenario. It's kind of same idea. Okay. And it doesn't matter how many position, velocity, acceleration problems I do with you. We can kind of configure them all different ways. And we're going to try to get the concept. So these might not be exactly the same problems like you see in the homework, and that's okay. You have to know when you're speeding up and slowing down, what to do. Okay. You have to know when it's changing direction, what you're going to look at, which is what we looked at, where the velocity was equal to 0. Okay. All right. So it says that for between 0 and 2, a bug is moving along the x-axis with the velocity of t squared times sine of t cubed minus 1.5t. Aren't you so glad I had you go get a calculator? Because we would have we'd have a product rule and a chain rule, and we'd have to set it equal to 0. That would be horrible, wouldn't it, on a Friday? So let's get this put into our calculator, okay? And I'm purposely picking on your graphing calculator versus just us opening Desmos. We know that would probably be easier, but I want to make sure you understand how to use the technology you have to use on the AP test, okay? So take a minute, get that put in. I work out a Scratchpad for the most part. We'll show you how to use some of the others as we get closer to the test, but we're going to stick with Scratchpad for now. Okay. And remember, I can't put T in there. So anytime you see a T, you have to put an X. That's, the reason why we want to make sure you practice with the calculator. Sine is hiding under the trig button. Once you've got it, go ahead and hit enter. Oh my goodness. That's quite a graph, isn't it? All right. It's an oscillating one, which means that when we remember how we said that there were times we didn't have derivative, like at a corner or cusp. One of the other times we don't have a derivative is when it's oscillating. So out over here, we don't really have a derivative. Okay, we can't take the derivative. However, if we notice in the problem, nope, not that one. Didn't they give us a nice little interval to work with? So we're really only looking at this from 0 to 2. So let's adjust our window in our calculator. So I'm going to go menu, window zoom, window settings, and I'm going to adjust my X from 0 to 2. Not super concerned about Y. It looked like I got the Y I needed on the graph. That's a little bit better. You can see it a little bit better. It's definitely not as crazy as the other one was. And if you also notice, we were nice enough to give you the picture of it there, so we can label on that picture. Their zoom was just a little different than ours, and that's okay. All right. So the first thing they want us to do is we're supposed to find we're supposed to find the acceleration at 0.7. Okay. So what was the equation that I'm starting with? Is it position, velocity, or acceleration? I'm starting in velocity. Okay. I have to get to acceleration. What am I going to need to do? Find the slope, which is also finding the what? The derivative. Don't we know how to do that in our calculators? How I showed you guys, didn't I? Let's practice it again, okay? I'm going to use the calculate page. You can also do it off the graph page. We've done it both ways, but I typically do it off of here. So we're going to hit the menu button. Where do you think I go from there? What class are we in? Calculus. Okay, and then I just pick on that first one there, numerical derivative at a point. That's really the only thing I use out of the calculus menu, because I can do the other one another way once we get to the third thing we have to learn this year. All right, so I'm going to put in, I'm on the wrong screen, 0.7. I'm just going to click OK. All right, where is my function hiding right now? Where did I type my function into? Do you remember? It's in F1. So remember, we use that var button to get back to that function, and then I have to type in X. And I'm going to hit enter. Okay, that's the value that I want. I'm going to write that down, but remember, I can't just write that number. I have to label it. Okay, if not, I won't get my points. So A of 0.7 equals negative 0.92. I totally forgot. 0.5. I guess I could just stop at the 0. I only have to show 3 decimal places. And again, you don't have to round. You can just chop it off. Rounding is where we can make mistakes, so we just chop it off. All right, we talked about this a few minutes ago. To determine if the bug is speeding up or slowing down, what do we have to do? What did we write down out here? What do we have to check? We have to look at the signs of velocity and acceleration, right? If the sign is the same, it's speeding up. If the sign is opposite, it's slowing down. So I have the value for acceleration. What do I still need to find? I need to find velocity. And I know we've got the graph, okay? I know we could probably look at 0.7 and estimate that it's down here and that it's negative. But it's safe to go into the calculator and just calculate it. And since that's the function that's in, we just want to calculate the value at F1. So I'm just going to go var F1 of 0.7 and hit enter. It's a nice negative number. I go there. All right, see if it'll let me paste it in there. It might not. Nope, didn't like where I wanted to paste it. All right. Oh, wow, look at where my thing moved to. Let's hit Control Z. That didn't help. Oh, there it did. All right, so negative 0.1318. Okay, so what do we notice about the signs of velocity and acceleration? They are the same. So what does that mean about the bug's speed? Is he slowing up or speeding up or slowing down? He's speeding up because the signs are the same, and we want to write why, okay? Because notice it says explain your reasoning. It'll say explain your reasoning, justify your answer, okay? One of those things. All right, so there's a couple of ways that we could write it. I'm going to show you both, okay? So the bug is speeding up because the acceleration at 0.7 is less than 0 and the velocity at 0.7 is less than 0. Or you could write the velocity and acceleration have the same sign. Your choice. Both of those would get you full credit. Okay. All right, let's look at the next part, part B. It says find any values of t in the interval between 1 and 2. So they've totally moved our interval again, right? I'm going between here and here now. When the bug is at rest. When the bug's at rest, is he moving? No. If he's at rest, he is stopped. So if the bug is stopped, let's go back up to that chart we had before. The bug is stopped. What does that mean about the velocity? It's equal to 0, right? So when we're at rest, that's another word for stopped. That means our velocity has to be equal to 0. Okay? Well, let's go look. What do I have the graph or the picture of or the function for? Position, velocity, acceleration. I have velocity. Okay? I know that I'm stopped when the velocity is equal to 0, which would be right there. Do I know what that point is just by looking at the graph? Unfortunately not, right? But I could find it with my calculator, couldn't I? So let's go into our calculator. I'm going to go back to the graph. And I want this one right here, right? That's the picture that we want. Because it also crosses over here somewhere and here, but the one isolated to that interval. So I'm going to go menu, analyze graph. What do I want to choose to get where it crosses? Intersection is when we've got two graphs. So what's my other option? What was it? We already said intersection was when the two graphs cross. Nope, we don't want an integral. We're not there yet. Let's go back and look at that again. Let me get out. Hang on, I gotta escape. All right, right there. Remember when we cross the x-axis, that's what we call a 0. All right, so which one do I want to pick? I want to pick 0. Okay, so remember, it's where your y value is equal to 0. Okay. All right, so I'm going to go to the left, go to the right. There's my t value right there that I'm going to use. Okay. All right, so it would be at t equals, oh, hang on, let me see. T equals 1.224. Oh, there's actually two places where it crosses between 0 and 2, isn't there? I totally missed that. Do you see how it crosses here again? Yeah, so we have to calculate both of them. All right. Sorry, I missed it on the first one there. All right, so I've got to grab that one too. So menu, analyze graph, 0, left to the right. Practice it on your calculator. I'll wait and let you catch up so you've got a chance to hit the buttons. Okay. Okay, so it's also at 1.801, right? So we probably want to write down, I'm going to write down why, even though it doesn't tell me. Again, it's helpful to have this when you're trying to do problems, okay? I should have probably said the bug is at rest. Rest at t equals this, because the velocity is equal to 0. Or you could write it in words, velocity is equal to 0. Okay. To do the next one, I'm going to write, I'm going to add to my graph a little bit. I'm going to just put these values. I'm not going to put the whole thing. I know that that's like 1.2 something, and this is 1.8. It just is going to help us identify in the next question here. Okay. Okay. So it says find the open intervals on 0 to 2 when the bug is moving to the right. Okay, we kind of talked about this in the last one. When we're moving to the right, is that a positive direction or a negative direction? Positive, right? We talked about it in the last question. When I am positive, am I above the x-axis or am I below the x-axis? I'm going to be above, right? So positive is above x-axis. So that's what I'm looking for, is an interval where I am above the x-axis. All right. I'm going to go back. Remember interval notation? I'm going to use interval notation this time. Okay. I'm going to try to figure out. I can use inequality. It doesn't matter, but I'm going to choose interval notation. All right. So between what two values of t or x is it above the x-axis? Above is right here, right? So what two x values is that between? 1 is here, right? So be specific. Where is it between? Exactly. 1.2 and 1.8, right? But I have to use the 3 decimals that we had here, okay? So we're going to say it's 1.224 to 1.801. Now, just like we were working on the context problems the other day, we can't just write that interval and move on. We really need to put it back in the context of the problem, okay, and make it a sentence. So I would say the bug is moving to the right when the velocity is greater than 0 or positive on the interval from 1.224 to 1.081. Okay. Okay, let's get through D, and then I think we're going to call it a day. Okay. All right, we got to find the acceleration of the bug when the velocity is equal to -1. Okay. So how do I get from velocity to acceleration? I take the derivative. Okay, so I know I have to do the derivative, which is slope, which is a rate. Okay. But I need to figure out where I need my derivative at. I have to figure out what number. Okay. So this one is like amped up a couple of levels here because they didn't give me a t, did they? They didn't say at t equals 1. They said when the velocity is equal to -1. So I need to figure out what the t value is when the velocity is equal to -1. So let's write out some notation here, and then we'll figure out that t value. So I would probably write that, or maybe the word when, okay? That arrow means it's a mathematical notation. It means implies. And that's okay notation to use. You'll see it a lot in scoring guides. All right, so we got t equals. This is good calculator work here that we're doing today. We're hitting all the parts of the calculator that we got to know. All right, so when I do a problem like this, I'm going to trick my calculator, okay? Don't I have two sides of an equation? I have the velocity side, which we know is sitting in F1, and we have another side that's just equal to -1. Technically, that's like a systems of equations where I've set it equal to each other, meaning I could solve it by finding a point of intersection, okay? So I'm going to hit tab, And in F2, I'm just going to put that -1 and hit enter. And now I'm going to find that intersection point right there. The intersection is my solution. So menu, what do I have to push from there? Analyze graph, and then what am I going to pick this time? This time I want to pick intersection. So I'm going to go to the left, to the right. And notice -1 is what we were kind of solving for. So this number in front, that x value is the point, is the t value. Okay. So I know that t equals 1.8368, something like that. Okay, but let's read our question again and see if we've answered it. It says we're supposed to find the acceleration of the bug when the velocity is equal to -1. Have I found the acceleration? No. I found the time when the velocity is equal to -1. What am I going to do with the time? What am I going to have to do to the velocity to get the acceleration? Take the derivative. So I'm going to take the derivative and I'm going to plug in this 1.8368 into that, which is also representing the acceleration at that point. Okay, so again, a lot of notation, not a lot of written work when we're doing the calculator. Okay. All right, so I'm going to go back here. I'm going to go to menu, calculus, numerical derivative at a point. Oh, I should have grabbed that. Hold on. I'm going to go back to the graph. Copy the point, right? So click once, click twice, Control C. Because if we do that, we get the most accurate answer. Remember, you want to carry at least 6 decimal places to be accurate. I'm going to go back here, then do menu, calculus, numerical derivative at a point, and Control V for paste. And then click OK. And then find your function, which is hiding in F1. Once you've got that, go ahead and hit enter. All right, I'm going to hit my enter button. All right, so -28.874. Okay. So it's equals -28.874. That's a 7. Okay. I think we've had it for now. Okay. So what we're going to do is we're going to finish up a good chunk of this lesson on Monday. At that point, I'm going to leave it to video. Probably the last example, example 7, we probably won't do together. The example 7 is already videoed and out there. So if you want to get a little bit ahead this weekend, you have enough knowledge to be able to do example 7 with the video. Okay. We will examine, we'll look at 5 and 6 on Monday. And then we've got to get into getting reviewed for a quiz on this. Okay. The other thing to look at this weekend, start looking through Aries, and I'm going to try to make sure things get updated. I'll send a text out when I'm completely updated. If there's any quiz you want to re-quiz, make sure you've look to do some corrections on it. Go back and start practicing the review again. Okay. You can re-quiz as many as you want. You can always come in at lunch next week before school. And then on finals day, you can take as many as you can in 75 minutes. Okay. But you're going to have to show me your review, at least the review assignment and your corrections. Okay. Or the homework assignment and your corrections. I'll take either one. Okay. So get a little bit ahead on that.